Now that we have Oracle up and running, we can start minting our stablecoins. In this video, we'll go over all the minting related on-chain and off-chain stuff. And in the next one, we're going to go over the burning and liquidating stuff. Okay, so let's start with the minting parameters. As you can see, we have 3 different minting parameters. 2 of them are the validator hashes of the Oracle and Collateral validators. By passing them as parameters, we make sure that this minting policy that we compile right now will only work for that specific Oracle and that specific collateral. That way, no one can change them after the fact. And the third one is the collateral min percent. A collateral min percent of 150, for example, means that the value of the locked collateral has to be at least 150% of the minted amount value. We'll see how we calculate that relationship in a bit. So then we have the mint redeemer. We have 3 options within minting policy. We can either mint, burn, or liquidate. Let's see which are the mint checks. So if we go here, we have 3 checks. To be able to mint a stablecoin, we have to make sure that the amount minted has to be positive. It has to be smaller than the maximum amount based on the value of the collateral. And we have to make sure that the transaction that mints the stablecoin creates an UTXO at the collateral's address with the correct values and structure. Those are the 3 only checks that the minting policy does, and the 3 only checks that this transaction has. Because when we mint, we don't need to run the collateral validator. We just need to create an UTXO at its address, and that's it. So let's see the first check. Let's check if the minted amount is positive. To check that, we just get the minted amount and check that it's bigger than 0. And how do we get the minted amount? We use the asset class value of function, the same we used with the NFT. But in this case, we give it the value of the tokens minted in this transaction. Using TXInfo mint, we get all the values minted in this transaction. And providing the minting values and the asset class of our own currency symbol, meaning this minting policy we are going over right now, and the stablecoin token name that we hard-coded before. Let's see. As you can see, this hard-coded value, we took this stablecoin token name outside of the validators because we use it both in the collateral and the minting policy validators. So it's just a hard-coded value of USDP. But you could put it as parameter if you wanted to, but you have to make sure that both the collateral validator and the minting policy have the same one. So it's just easier to extract it. And with that, we get the number as an integer of the stablecoins minted in this transaction. We just compare it to make sure that it's bigger than 0, and that's it. Now let's go back to our checks. The second check, we have to make sure that we don't mint more than we are allowed to. So let's go to check max mint out. And as you can see, we pass this collateral output amount to this max mint that calculates the maximum amount we can mint with this collateral and check that this maximum is bigger or equal than the minted amount we got before. This max mint function is the one that actually calculates the relationship between the amount of collateral and the stablecoins being minted. And it's just math. It's a simple formula. The second term is the original formula. And the third term is a simplification that we can do based on the numbers. So at the end of the day, we get this max mint formula that takes into account the collateral amount, the minimum percent allowed of the collateral, and the current rate provided by the Oracle. and uses that to calculate the maximum mint allowed. And this rate comes from the Oracle. So let's go see how we can get that. As you can see here, we are using the parse Oracle datum we saw in the Oracle lesson. As you recall, this parse Oracle datum took a tx out, a tx info, and return maybe the rate as an integer. So we have to provide the tx out and the tx info. And if we get nothing, that means the Oracle is either not there or it's there but has the wrong datum. And if it succeeds, it just returns the rate. To get the Oracle input, we just take all the inputs and then filter the ones that have the address equals to the Oracle's validator's address. As you recall, we have the address of the Oracle validator in our minting policy parameters. So the only thing we have to do is to check that this Oracle's hash is inside just one of our TXO addresses, and we found our Oracle. Because there can only be a single Oracle, we pattern match to extract it. If we don't get this single Oracle, that means there was an error. The Oracle wasn't there, so we just return an error. Notice that here I'm using tx info reference input. I'm referencing the Oracle, not consuming it. That's how we get the Oracle's inputs, and then we use it to parse the datum with that function. Once we get the datum, we can use it to calculate the max mint that we use to check that the minted amount is smaller or equal than the max amount. That was one of the most complicated checks we needed to do, maybe the most complicated. And finally, the last check is to check that the datum that the transaction creates at the collateral's address has the correct values and the correct datum. This is pretty simple. We just get the collateral's output datum, and if there's nothing there, we return false because our transaction is not creating the value, so it shouldn't be allowed to pass. But if there is a collateral output datum, we take the datum and say, okay, the minting policy ID of the datum has to be the same as the policy ID of this script. That's one of the checks. With that check, we make sure that we are not creating a datum for a different stablecoin. Then we have to make sure that the datum contains the same stablecoin amount that we minted in this transaction. And finally, we have to make sure that this transaction was signed by the collateral owner specified in the datum. With those three checks, we make sure that the final datum has the correct values and amounts, and we can rest assured that only the actual owner, the person that minted the stablecoins, can later redeem it. And how do we got the actual collateral output datum? Well, if we go to this function, we see that we use the parse collateral datum function and we provided an output datum. And this output datum came from this collateral output function. So let's go step by step. This parse collateral datum is just a convenient function, same as the one that we use for the Oracle's datum. But in this case, we check that the type of the return amount has to be the collateral's datum, not an integer. Actually, that's the only difference between when we parse the Oracle's datum and when we pass the collateral datum. We have to make sure that we return the correct type. And the collateral's datum type, now that we're here, let's take a look at it, has the same structure we built in our minting policy. We have to provide the minting policy ID, who's the owner of the specific collateral, and what's the amount of stablecoins that were minted using this collateral. We'll see more in the next lesson, but for now, let's go back step by step. Now that we got parse collateral datum function, let's see how do we get this datum without parsing that we got from this collateral output function. If we go here, we use the script outputs add function that takes a validator hash and a txinfo and returns all the outputs that this transaction creates at that particular validator hash. And because we want to check for the collateral's outputs, we pass it the collateral validator value. Because we know that this transaction should create a single collateral output, we pattern match to extract it when the first one is the datum and the second one is the value. And that's how we get our collateral output. When we want to get the datum, we just parse the collateral datum, and that's it. By doing all this, we did all 3 checks needed for the minting policy. Now let's see how we can construct a transaction that satisfies all these checks. So let's go to the stablecoin component that has the mint stablecoin function. Here we are. And this function to mint the stablecoins does a few checks to make sure we have Lucid running, we have the address, we have the Oracle's NFT, we have everything we needed to actually perform the transaction. The amount to mint is bigger than 0. We do these checks in the front end to avoid running the off-chain code and checking and say like our transaction is wrong. But all these checks are just front-end stuff, nothing important. Now let's go to the actual off-chain code. First, we get our PPP hash, the one from the address is connected right now. Then we create the collateral datum we want to put at the collateral's address. As you can see, it has the minting policy ID, it has the collateral owner, and the stablecoin amount. To create this collateral datum, we also have to create the type collateral datum. It has the same structure, but it's a way to give Lucid the structure of the value so it then can parse it to the correct hex. So if we go to the collateral datum, we see that it's an object that has the minting policy ID in bytes, the collateral owner in bytes, and the stablecoin amount in integers. And this object is a type of name collateral datum. Let's go back. So we have our PPP hash, we have our collateral datum. Now we have to get the collateral's address that we can derive it from this collateral script because the collateral is not parameterized. I can use the same collateral for different minting policies. So if we go to the collateral script, this is the state of our app. We go to the top, you can see that I hard-coded the collateral script at the very top of the app. And I provided at the very beginning of the state of the app because this is the only script that doesn't need parameters. It's always the same one. That's it. So we go back. We use that collateral script to get the collateral script address. And now we have everything to build a transaction. Let's go, let's make center it. So we create a new transaction. And this transaction has to read from the Oracle with NFT UTXO and the minting policy reference script UTXO. We use this read from function to read from both reference input and reference scripts. Because we don't need to run the collateral validator right now, we just need the Oracle and the minting policy. Then we have to pay to the contract, we have to create the UTXO, at the collateral address. So we use the pay to contract function and we provide the collateral address and the datum we want to create. The datum is of type collateral datum, is an inline datum. This way, other people can see the datum and check if you can be liquidated or not. And finally, we provide the value we have to lock. In this case, we get this collateral value to lock from the UI. As we saw in the second video, you can just write the amount of collateral you want to create. And because we write the amount in ADA in the UI, we have to multiply to get the value of Lovelesses. And we also want to actually mint the stablecoins for ourselves. We are paying everything we need to do and we are creating the correct item, so we might as well get paid as well. We use this mint asset function to mint the stablecoin currency asset using the amount we wrote in the UI. And because we're actually running this script, we have to provide the redeemer, in this case, the redeemer of value mint. We also created this type in Lucid that, as you can see, is an enum of type mint, burn, and liquidate. So we mint the asset, we create the UTXO. The only thing left to do is to add ourselves as signers to make sure the minting policy validates our transaction. We balance the transaction and sign and submit. And that's it. That's everything we need to provide as off-chain code to create the transaction we need.